Thank you guys so much for coming. I am very excited to talk to you guys about maps today. So let's have a mappy time with it. Yeah. All right. One thing I do want to say, because I realized I forgot to put in the slides, is it is the month of November right now, and there is a fun, just community-driven challenge that's happening all over like social media. It's called the 30-day map challenge. I've fallen a couple days behind because of prep for this, but I will be posting a different map each day, and so several others will throughout the community as well. So if you want to find some cool maps, and each day has a different theme, so look out for that. All right, so let's go ahead and talk about open source web mapping libraries. And actually, before we do that, let me go ahead and introduce myself. My name is Courtney Yatteau. I am a developer advocate at Esri. Has anyone heard of Esri? Okay, yeah, a few. Nice. Yeah, it is a GIS company, or Geographic Information Systems. Very simply, they do lots of different mapping stuff, but they do so much more than just basic maps. We've got so many different businesses that use us. We've got so many different governments that use us, and so many different factions. So lots of different places you can find Esri. All right, so before I joined Esri, I actually was a high school math and computer science teacher, and I did that for 10 years. And I took my computer science skills and translated them into what I do now. So maps were actually new to me about 3.5 years ago, and over the last 3.5 years, it's been a lot of fun getting to play around with all sorts of different libraries, especially the open source ones. A couple of them that I'll show you today. All right, so here's the agenda, and right away, if you want to follow along, if you happen to have your computer with you, or if you just want to go ahead and bring up that link on your phone and use it later, but that is going to be all the slides and all of the demos that I will be showing you today. So if you jump right to that, you can follow along. So here is our agenda for today. We are going to start with some vocabulary, some concepts. I did realize that when I first got into the GIS world, there is so much in terms of terminology that is difficult to understand. So I'm going to be sure to clear up some of those things so you understand what they are before I actually show them in the demos. And then we will look at 2 different web mapping libraries. We're actually going to look at a few extra libraries as well, but they are more of like helpers or plugins to the 2 main libraries that we'll be looking at. All right, and that is exactly what I was saying about the other library integrations. And then finally, we will look for some conclusions. So we'll see a couple of real-world examples and some summaries. Okay, so let's start with the role of mapping. So there are several different ways you can use maps. First one, visualization. So maps help turn raw data into visual insights. So for example, we've got that top one there. That is a simple map where we've got a bunch of individual points that just represent data. So those could be POI, or points of interest. Then that middle one, that is a clustered map. And that does group the points together to reveal some kind of pattern in dense data sets. So when you have a larger group of data, you may want to help visualize it in a different way, and clustering could help with that. You can see where the concentrations are. And then that bottom one there, that is a heat map. And that does help visually emphasize areas of high concentration. So just a different way to visualize the data in terms of, we have the clustering and then we've got the heat map. So 2 different ways. And there are so many other different ways, but these are just a couple very common examples. All right. Next one is navigation, which I'm sure almost all of us use on a at least weekly, potentially daily basis. So mapping, of course, is not just about creating pretty visualizations, it's about guiding users to where they need to go. So maps with routing and directions, they can simplify, obviously, complex routes and help navigate you from point A to point B. Now, if in a consumer sense, it's pretty straightforward. It's just taking you, like I just said, from point A to point B. But there are so many other ways to use routing in various different industries. You could think about having to have, say, a bunch of different delivery vehicles, having to go to all these different delivery deliveries, you kind of have to optimize the paths that they're going to take. So that is just one example. There are several different examples you could find throughout the GIS world. All right, so the next one is communication. So maps do help serve as powerful communication tools. So in real-time apps, like say maybe some kind of food delivery ones, or maybe even like location-based social media ones, this can help keep users informed about the current locations and the movements. So if you're tracking maybe where your food is, or if you want to see what your friend's up to today, if they have their location turned on. So this immediate visual feedback, it does help better that, say, connectivity and interaction really between the services and the users. And then the fourth one is prediction. So this really is essential for forecasting. So whether it's maybe predicting the path of, say, a storm or forecasting the different traffic trends, maps can really help us anticipate the future events. So they help create that visualization of what may potentially happen. And this predictive power, it does enable us with like better planning and decision making, of course. And it ultimately could help us avoid potential catastrophes or delays. Okay. Now we have 3 key web mapping concepts that I'm going to describe to you. And the first one is base maps. So I remember learning this term and thought, base maps, I mean, isn't that just a map? Well, base maps really are that foundational layer, right? So they set the geographic context of what you're looking at. So they provide that, say, like canvas area where additional data can then be laid on top of it. So you can really think about them as like the background image of your map, helping to establish that visual reference. And then after you have your simple base map, you can then layer different pieces of data on top of it. So data layers, these are elements that add meaningful information right on top of your base map, so they can bring your map to life by displaying all sorts of things. You got points, you got lines, you got polygons, and these can represent, of course, different real-world features. Typically, we'll call the pieces of data features. And these could help highlight specific like data and trends that the base map maybe alone could not show. You'll also see a lot of times there will be geographers or GIS people that are really picky about the particular type of base map they're using and then overlaying the data on top of it, because potentially that base map maybe helps the data pop. So say maybe you just want to use a very dark base map or a very light base map and have your data be really visual on there. And of course, the more layers you get, the more insights you could potentially have as well into how different pieces of data connect together. And then finally, we have geocoding. And of course, geocoding, it is the process of converting addresses or places to geographic coordinates. So we're able to actually place them on the map in our real world. And of course, it's essential for integrating textual data with visual map representations. So this could enable like location-based features such as searching for places or even routing as well. So it's really a key element that's needed for a lot of different other functionalities that we use maps for. All right, we're gonna look at 2 different kinds of base map formats. Okay, so we have 2 different ways that we can represent our real world on the web. And the first one is pretty straightforward. It's a very fixed look. So this is known as raster tiles. And these are essentially like printed photos of your map. They will always look the same every time you load them. And this is really good for, say, potentially things like satellite images or very basic standard street maps that you may want the appearance to just stay the same. They are really easy to use. So since they are pre-made images, you don't have to worry about changing anything in the styling versus the other type that we'll look at. And so yeah, very straightforward, very easy to use, and they are very reliable when you do have a low bandwidth area or connectivity. So the other type is vector tiles. And so vector tiles, these are actually they're kind of like a blank canvas. So because they're built from data that's defined by mathematical formulas rather than just fixed photographic images, you really can change the colors, the labels, the styles, all on the fly to really match your needs for what you want. Now, since vector tiles are actually rendered on the user's device, they can update quickly when the underlying data potentially changes. So, for example, a good example is if you're showing real-time traffic, the map can smoothly adjust to display current conditions without needing to download new image tiles like you would with, say, raster tiles. And vector tiles are much lighter and can scale definitely more easily across different devices. So basically this means that your map will stay fast and very interactive when you're handling a lot of different pieces of data. So it depends on your situation, right? Rasters, again, they're made up of just pixels. Vector images, of course, or vector tiles, sorry, are made up of paths that are defined by the mathematical formulas. So depending on your use case, choose one or the other. All right, so let's look at some different base map styles. Now, these are certainly not all of them. This is not an exhaustive list, but this is some of the most common ones that you'll come across. So the first one is what's known as usually the street style, the street base map style. So this is a really classic map that you'll see in many navigation apps. It will clearly show your roads, your landmarks, your place names, and it does make it really ideal for where users need to find their way around. The next one is satellite imagery. And of course, this provides real world imagery. So it gives you a realistic view of the area, which is good for applications maybe needing context for that kind of maybe a situation of environmental monitoring or maybe potentially even real estate. All right, so the next one is terrain or topographic. So these maps do highlight actual physical features like hills and valleys and the elevations. A lot of times you'll see actual elevation numbers on these base maps. So they're especially useful for outdoor applications where understanding that the landscape is truly important. All right, and then you have dark and light modes. And so I did mention this a minute ago, but yeah, so modern apps offer these dark and light modes. A dark base map can reduce eye strain potentially in low light conditions, while a light one can actually make data overlays stand out, like I mentioned a minute ago, in bright environments. And then finally, my favorite, because I love a lot of, I'm more of a front-end developer than anything else. So I do love to actually create my own base map styles. So you can create your own custom styles that match, say, maybe your app's branding or whatever it may be that you're feeling in the moment. I've done fun holiday ones just because. So this really is useful when you need a map to show some specific type of design or maybe create a specific type of user experience for your application. There are many different tools that you can use online to do this. I will be providing a couple of different resources in the slides for you, and I'll mention a couple as we go through. All right, next is the data layer types. So I mentioned data layers when we were talking about the general map concepts. So let's talk about 3 specific different data layer types. Now these aren't all of them, but these are, I would say, some of the most common ones. And so the first one is going to be your simple GeoJSON layer. I'm sure almost all of us have worked with JSON before, and when you add the little bit of geo to it, really all it does is give location context to a JSON file. So they're very lightweight. They're easy to use and load and parse. They're good for small or medium data sets. Of course, it's all of it's just thrown on the client right there, right away. So if you have a really large data set, probably not going to be your best bet. But if you got something small, maybe anywhere from, I don't know, it depends on the type of library you're using, but I would say I've had success with like about 100 points, maybe even 200, but really once you're starting to get into the thousands, it depends on a lot of different various factors. So let's say you do have a bit of a larger data set. There is what's known as an Esri feature layer, and this just is one type of way to actually host JSON data on the web, right? So basically you're hosting it in the ArcGIS servers, but there's various different other companies that have different ones as well. So if you do use this specific one, it's basically the JSON data is not all served at once. So it's not just loading that client with everything. So it is ideal for frequently updating or frequently updated data sets. So data sets that are, changing. Not specifically real time. That's actually something a bit different that we won't talk about today, but something that may need to stay live. So maybe you want to be able to edit it. You want to be able to query it, filter it, that kind of thing. And then finally, we have our vector tile layer. So if you have a set of data that you want to, it's a huge set of data, and you tried maybe, say, using a feature layer, but it's still so large and it's having a hard time loading all of it, you could actually create what's called a vector tile layer. And so this really delivers vector data, right? Just like I was talking about vector-based maps. And this is going to be really fast client-side rendering. It's optimized, of course, for that fast rendering because it's pre-tiled and it's very minimal. So basically, it's created into PBF, a PBF file, and not JSON. So it's a binary set of tiles. All right, let's look at some library commonalities. We're getting close to our demos soon. So the first thing is the commonalities between the two libraries, and I haven't mentioned the two libraries yet, I'll get to that in a minute. But the commonalities we have among these two major ones that we'll be looking at is they are built on JavaScript, and so they are compatible with HTML and CSS. And of course, they're going to work nicely across all of your different modern browsers. Okay, they are all open source. So few things behind that. Cost effectiveness, right? So you've got no licensing fees, you've got budget-friendly prototyping, and your resource allocation. You have a huge community. It's very nice. You've got a lot of active contributors for especially these two libraries. Last month was Hacktoberfest. I saw a lot of kind of traction going on around there. So yeah, lots of support. And you've got a lot of different plugins as well. And we'll look at some of those. And they're modifiable. So of course you have the full source code available to you. And they're interoperable, so you got your open standards, they're cross-platform, you have data compatibility, and of course, just very easy to use, very seamless to integrate into your apps. All right, and they are easy to learn. So basically, they offer simple APIs so that you can get a map up and running really quickly, a few lines of code. So you'll see how quick it is, especially for this first demo. And they do come with lots of documentation, and if you can't find the answer to something there, of course you could find it somewhere else, because I'm sure someone's asked that question before. But again, that kind of ties back to the community as well. And because they're so widely used, there's tons of different resources online that people have created, not just directly on their own sites, but throughout the community. And finally, we have our key features. So they are very interactive and mobile friendly, meaning you can pan and zoom and tap features very smoothly, whether you're on, say, a desktop or your phone. And they're very customizable, so you can control the look and the behavior of your map as much or as little as you want to. And most importantly, they do use the Web Mercator projection, which I'm not going to get into the details of that, but essentially that just is the projection that we are all used to seeing, say potentially in Apple or Google Maps. It's the very easiest, most adoptive way that we've decided to use on the web to turn our spherical world into a flat surface. Okay, so let's look at a couple libraries. The first one is Leaflet. Has anyone used Leaflet before? Nice. Awesome. Okay, so some advantages to Leaflet. It is super lightweight, just about 42 kilobytes of JavaScript, very minimal footprint for loading, and a very low overhead. And it has tons of plugins. We're going to look at a few of them today, but there are just so many out there. I've got a link to majority of them at the end of the slides. And it focuses really on simplicity and performance. So again, it's going to be a use case situation, whether you want to use this library or potentially the other one or another one. But it does prioritize those fast, responsive map interactions. All right, so then we have another open source library that pairs along really well with Leaflet, and this is Esri Leaflet. So this is an open source library that was actually created in 2013 to help bridge the gap between Leaflet and using some of Esri's location services. So this library allows for a very nice seamless ArcGIS integration. So again, it just allows you to very easily take in those ArcGIS REST APIs into your Leaflet map. And it's very developer friendly. There is documentation at that link. It does very easily leverage the Leaflet interface and everything. It doesn't make you change anything about if you're already using Leaflet, you can easily just start using this. Yeah, it basically has helped reduce the learning curve. And it's very modular as well. And I just mentioned it, there's tons of documentation for you to look at different tutorials and guides and that kind of thing. All right, and then the last thing I want to mention before demos is Nominatum. This is a search and geocoding API that's built on OpenStreetMap data. So one of our demos is going to use this. So it very nicely does your geocoding process, place names or addresses to coordinates. It returns GeoJSON and metadata. So there's a lot of metadata that comes with it. So it can make it really easy for you to do all sorts of things, like potentially, say, directly zoom to a feature or, of course, label something. All right, and Nominatum is used by many different Leaflet plugins that have been created by the community, one of which I will be showing soon. All right, and of course it's free to use and open to everyone, which makes it really a great choice for developers that are experimenting with geocoding. All right, so I have a set of demos that we're going to look at with Leaflet. The way that I'm going to go through these is I built them very simply so you can just get up and coding with it real quickly. So I just put them all in basic code pens where I'll just be kind of showing you the different steps throughout. All right, this is the first one. So we are centered on Malmo here, and we are using the OpenStreetMap base map, the most probably common one you'll see across open source web mapping libraries. It's the one that Leaflet uses for their intro demo. Let me talk a bit about the code, and then I will do a couple of things we'll keep an eye on the map because I'll be doing a little bit of interactivity there. One thing I do want to show there real quick is as I zoom in, you'll see that all of a sudden you can see the individual base map tiles. Honestly, that's really just because it can't handle fractional pixels very well. The tiles don't. So you just want to keep it at what it's really meant to be at, that proper zoom level. There are things you could do in the CSS to potentially mitigate that issue, but just a heads up. All right, so let me zoom in on the code a bit. Okay, so for simplicity, I did actually use just CDN to bring in the Leaflet CSS and JavaScript. And one key thing to realize is that whenever you're using either one of these mapping libraries, you do have to give the map a height. Otherwise, you won't see the map at all. All right, and that map is tied to a div ID. So when you get into your JavaScript, you do want to link this part here to that ID. You're going to set your view. Now in Leaflet, it actually goes latitude, comma, longitude versus the other mapping libraries the other way around. So, not sure why. And then this last number here is the zoom level. So I have it at 13 right now. Depending on the base map style, you can go up to anywhere from potentially 18, 19, all the way to 20 something. But I think this one can only go up to about 18, 19. With a, otherwise you won't have tiles after that. All right, and then this is the actual tile URL that I've used. So as you can see, these are just simple PNG tiles that are coming in. It's the OpenStreetMap style, and of course we want to use the attribution. So let me show you a couple other styles. Let's look at this HOT style, which is a humanitarian style by the Humanitarian OpenStreetMap team. So I will change that out. Let's see it change. There we go. So we have a bit of a different visual look here. So it highlights, this one highlights different roads and buildings, and it says, and settlements for crisis mapping. So apparently that's what this base map style was designed for. And then let me show you one more. We've got a topographic one right here. Zoom up. There we go. I'm so far zoomed in. Let me zoom out. Okay, there we go. So then we have a topographic style. And we mentioned topographic earlier, things like elevation, like outdoor applications, that kind of thing. All right, so as you can see, I mean, that's really it. That's all the code you need to get a simple map on your site, like right away on your web app. You can do other various things, like here, I'm gonna go ahead and uncomment out all of this. And what this is this is just a simple set of GeoJSON data here. So let me just uncomment all of this out so you can see it. And we will see all the pins show up. And again, simple GeoJSON data set, so it's just got the name of each one. I did add a pop-up to each one of these as well, so you could see that in the code. But yeah, it's pretty straightforward. Again, all on the client. This data set, I think it's like 20-something points, so very small, easy to handle. All right, on to the next demo. So the next one is we are going to be looking at, once again, we have our base map is the OpenStreetMap base map, but this one I want to show you a feature layer and then some clustering. Now this feature layer is a huge feature layer. Actually, the second one is. Let's look at the first one so I don't overload my computer. All right. So the first one, this is actually just the municipalities of Sweden. So let me go ahead and uncomment that out. And this is a polygon feature layer. There you go. So if you're curious about where to find data, there are several different places you can find different data sets. This one I actually just found by searching Sweden Open Data CSV or something like that. You could say GeoJSON as well. There is, in the additional resources at the end of the slides, there is a specific one for Sweden there. There's also a more general one that's just called the ArcGIS Hub that you can find all sorts of open, free data to use in your apps. Now, because it's a feature layer, I have hosted it in the ArcGIS servers. So that is this URL there. All right, let me go ahead and undo that. Let me make sure I'm still connected to the internet. Okay, I am. Let's go ahead and, oh, actually, before I do, no, I'll go ahead and do it. Okay. So this actually, I'm so far zoomed out that it should actually show up pretty quickly. Okay, good. That is actually 53,466 points. But because I'm so far zoomed out, it's able to just say, oh, okay, we know that it's just going to be a bunch of points on top of it. We can show that visually really quickly, right? If I start to zoom in, it's going to lag a bunch. It's going to bog down quite a bit. So here's what I'm going to do. I'm going to take that away. I'm going to zoom in pretty far. Let's go into like 18. Okay, I believe 18 is actually probably the furthest we can zoom in on this specific base map. So let me go ahead and show this feature layer again. Now, just so you know, this is all of the addresses in Malmö. So all of the address points, hence 53,000. There you go. Okay, so we're only seeing a portion of them, and it came up pretty quickly, right? That's because I was so far zoomed in. So again, it's able to detect, hey, within those bounds, we can show that much of that feature layer. But as I continue to zoom out, it will definitely have a hard time starting to show the rest of them. It's quite a bit. Okay. So what can you do? Well, we have different visualization options we can do with our points, right? One of them, I won't worry about showing this, but there are ways to style those points as well. So let's go ahead and cluster them. And before I do that, let me zoom out a bit more, because if we're so far zoomed in, the clustering's not going to mean much. There we go. All right, so we have some clusters here. I did a very simple, just default clustering. So as you zoom in, it's just going to cluster them until you get up to the very furthest you can zoom in. But there are, of course, various different properties you can use. This one, for example, is disable clustering at zoom 17, right? There's so many different other options. You could say, enable it at a certain point. You could say only cluster this many together, that kind of thing. But of course, as you could see, it loaded a lot quicker because we've clustered them together. We didn't have to show each individual point. Okay, next demo. So this one is another Leaflet one, and it is going to be using GeoSearch. We are going to use the ArcGIS World Geocoder, so it's just the general geocoder that Esri has, and then we are also going to GeoSearch a feature layer as well, which is kind of fun. So we've got our basic setup. We've got a little bit more of the CDN stuff to help bring in some of this information. We've got right here. Okay, I can zoom in a bit so you guys can see that. So we are going to be using, like I said, the GeoSearch option. One thing is to keep in mind if you use this, the default is to actually use the map bounds. So I'm setting that to false so it can just search for the whole world. My providers, like I mentioned. And of course, with something like this, you'll need your access token. I know I just showed mine. It'll be inactive in like an hour, so. All right, let me go ahead and search this here. Okay, I'm going to search for something that is just randomly around the world. So let's look for, I don't know, Paris. Okay, cool. And we get the top 5 options there. Many different properties you could use to change that as well. You could say I want maybe the top 8 options, or maybe I only want options that start with so many letters, that kind of thing. So you can do all sorts of filtering with that. So one of the filtering options is maybe I only want options to show up as places that are in the country of Sweden. So let's try again. Okay, so now as we can see, it's not showing Paris, France anymore. It's showing Paris, Sweden, which I guess is a place. All right. And then another one you could do is you could actually filter by specific categories. So maybe instead of actually filtering by like cities and countries and POIs and that kind of thing, you could just filter by specific addresses. So now when I type it in, it's starting to show only specific addresses. So potentially Paris being that part of the street name or whatever it may be. All right. The other thing that I mentioned is searching a feature layer. So let me get rid of that one. And now we're going to search through our addresses feature layer that I just showed a minute ago, all of those different addresses in Malmo. So in order to do that, you do have to understand a little bit about the actual layer itself. If you were to just follow this URL, you would be shown all of the different fields that you're able to utilize within that layer. So our search fields here, I've just decided to search for the address. And when I actually format the suggestions here, you'll see that there's going to be an address, and then there's also going to be the postal code with it. I just start typing something. And, let's try that again. There it goes. I guess SEA doesn't have any in the feature layer, so SE worked though. So we've got address and postal code. If I click on it, you'll see the pop-up automatically come with that specific location. So that is one other way to use GeoSearch. All right. The final Leaflet demo I want to show you, and this is real quick, this is using the Nominatum geocoding service, and it's actually using a plugin. It's the highlight plugin. It's pretty straightforward. Basically, all you have to do is, in this case, I've set the filter to polygon. You could set it to, line or point, but I've set it to polygon. I said, hey, highlight this. That's my query. Highlight literally this building here. So it worked. Oh, actually, I got to refresh that. That's the Malmo Arena. There it is. All right, so, but of course, if I change it to Malmo Arena, then it will actually highlight the Malmo Arena. And there it goes. Cool. So a fun little plugin that you can use. You could style it as well. But again, that's just something that a community member made to help users of Leaflet out. All right, I'm going to go back to my slides. I'm going to speed it up just a little bit. So we've got some takeaways. Generally, we had our simple map, we had our large data sets are good for, say, potentially feature layers as long as you do some sort of styling or are zoomed in or out. We'll look at vector tiles, which is the alternative to that in MapLibre. You've got your geo search option, and then we had our nominatum highlighting. So let's look at MapLibre GLJS. Has anyone used MapLibre before? Okay, so it is a bit more powerful of a library to use. So it's a fork of Mapbox GLJS. It uses WebGL rendering. Basically, it's going to handle vector tiles really, really well. And lots of different custom styling options. We also have the MapLibre ArcGIS plugin. This is actually brand new. It came out at the end of September. It's very similar to Esri Leaflet in that it helps integrating with ArcGIS pretty easily. So it allows you to bring in your base map styles, feature services, and vector tile services very simply. And finally, there is also ArcGIS REST.js, which actually works with any open source libraries. Of course, this itself is also open source. It can work with any open source mapping libraries. It doesn't have a map itself. It's really just a wrapper around the ArcGIS REST APIs. So let's look at my last couple demos real quick. So the MapLibre setup is very similar to Leaflet. I've got my CDNs and all of that. One thing I mentioned earlier, longitude, latitude. We've got this style is one that I've already plugged in here. I use the MapTiler style here, which is MapTiler is just another option to create your own base maps potentially, or they also have plenty of different vector-based maps. And that's the biggest difference between this and Leaflet. Leaflet was all PNGs that I showed you. These are all vector-based maps. So we've got that one. Actually, sorry, I had that one commented out. That was actually ArcGIS navigation. This one is the MapTiler one. I mixed them up. So that's the simple setup. The next one, this is all of those addresses again. This took a solid like 20 seconds for it to load, so I'm not going to reload the page right now. Just trust me, that's what happened here. So one thing I want to show you is another way you could potentially use a feature layer is you could actually query it. So if you wanted to do the querying of that, let me open that up here. Here we go. Okay. We are going to get rid of this source and layer, and we're going to add this source and layer to query it. So that way, instead of saying, show me all of the addresses at once, I can query it at a specific location, which, almost there. Did I miss something? Okay. Oh, there it goes. It was just the delay. So basically, you can just click, and it's within a specific radius there. It tells you, hey, here's the features in that area. And then finally, the last thing is the vector tile layer, which I need to undo what I just did and get rid of this. Actually, I can get rid of this entirely and show this. And this is going to be the same exact data set of all those addresses, but it's shown as a vector tile layer, so it's much faster. Also, it's already styled, pre-styled. You can change that as well within your settings. All right, so I have almost run out of time, so I'm going to go ahead and skip the last demo. Just know it's pretty cool. Check it out. It's all about data enrichment. So these are a couple real-world examples. The first one is the Swedish Meteorological and Hydrological Institute. They do use Leaflet for several of their weather and hydrological visualizations. And then MapQuest actually does use MapLibre for their routing and directions application. So we have some conclusions. The Leaflet is very lightweight. It's got plugins. It's not the greatest for potentially larger data sets, though, because it doesn't handle vector tiles very well. It can, but it's not optimized for that. Versus that's what MapLibre is optimized for, is handling those larger data sets. It can be a bit more resource intensive, though. So if you're just trying to show a few points on the map, maybe use Leaflet. But if you're trying to show something a bit more intensive, MapLibre would be the way to go. Got a bunch of different additional resources. I also have several different videos I've made on my own personal YouTube channel about Esri Leaflet and MapLibre and plenty of other different mapping libraries and plugins. And that's it. Thank you guys so much. Let me know if you have any questions. Come talk to me. I'm available. And happy coding.